Hello. Now let's solve practice set 3.4. Question first. In figure, in a circle with center O, length of chord AB is equal to the radius of the circle. Find measure of each of the following. Angle AOB, angle ACB, arc AB, arc ACB. Okay. Now let's find values of these questions or values of these angles and these arcs one by one. From given information, AB equals a radius of a circle, but actually OA and OB are radii of a circle. As OA and OB are radii and AB equal to the radius, then we may conclude that OA equals OB equals AB. Okay, means all the sides of triangle OAB are equal and therefore triangle OAB is an equilateral triangle. And we know that every angle of equilateral triangle have measure 60 degree and therefore angle AOB will have measure 60 degree. Angle OAB will have measure 60 degree and angle OBA will have measure 60 degree. Now, angle AOB is a central subtended angle by an arc AB. And by the definition of measure of an arc, measure of arc AB equals measure of angle AOB, and therefore measure of angle AOB equals 60 degree, and hence measure of arc AB will be again 60 degree. Now angle ACB is an inscribed angle, and measure of inscribed angle is half of the measure of its intercepted arc, means angle ACB equals half of measure of arc AB. By inscribed angle theorem means half of 60 degree means it will be 30 degree. While finding measure of arc ACB, we will consider a complete circle. Measure of arc AB plus measure of arc ACB equals 360 degree, since angular measure of circle is 360 degree. As measure of arc AB is 60, we will come to the conclusion that measure of arc ACB equals 300 degree. Okay, now let's mention these things step by step. Here, in circle with center O, with center O, OA equals OB equals radius and AB equals radius. Since it is given, and therefore in a triangle OAB, OA equals OB equals AB, and therefore triangle OAB is an equilateral triangle, and therefore angle AOB equals angle OAB equals angle OBA equals 60 degree. Since angle of equilateral triangle, okay, and therefore angle AOB equals 60 degree. Let's call it as equation first, and therefore or now measure of arc AB equals angle AOB by definition of measure of minor arc. Okay, and therefore measure of arc AB equals 60 degree. Equation second. Now angle ACB equals half of measure of arc AB by inscribed angle theorem. That equals half into 60 degree and it will be 30 degree. 2 1s are 2, 2 3s are 6, 2 0 0, and therefore angle ACB equals 30 degree. Let's call it as equation third. Now measure of arc AB plus measure of arc ACB equals 360 degree. Since angular measure of circle is 360 degree, and therefore 60 degree plus measure of arc ACB equals 360 degree, and therefore measure of arc ACB equals 360 degree minus 60 degree. Therefore measure of arc ACB is equals 300 degree. Let's call it as equation fourth. Now let's see question second. In figure, quadrilateral PQRS is a cyclic. Side PQ congruent side RQ. Side PQ congruent side RQ. Okay. Angle PSR equals 110 degree. Angle PSR equals 110 degree. Find measure of angle PQR. Yes, you may know. Angle PSR and angle PQR are opposite angles of cyclic quadrilateral. And we learned cyclic quadrilateral theorem. According to cyclic quadrilateral theorem, opposite angles of cyclic quadrilateral are supplementary. Means angle PSR plus angle PQR equals 180 degree. And as angle PSR having measure 110, angle PQR will have measure 70 degree. Okay. Then measure of arc PQR. Measure of arc PQR. Arc PQR is intercepted by inscribed angle PSR. Okay. And we know that measure of inscribed angle is half of the measure of its intercepted arc. Conversely, we may say measure of intercepted arc is equals twice of angle inscribed angle which intercept that arc. Means measure of arc PQR will be twice of 110, means it will be 220 degree. Measure of arc QR we will find, and measure of angle PRQ also we can find. Okay, now let's find values of these angles and these measures one by one. Okay, from figure or here, quadrilateral PQRS is cyclic. Okay, and therefore angle PQR plus angle PSR equals 180 degree. Since opposite angles of cyclic quadrilateral, and therefore angle PQR plus 110 degree equals 180 degree. And therefore angle PQR equals 180 degree minus 110 degree. And therefore angle PQR equals 70 degree. Let's call it as equation first. Okay. Now angle PSR equals half of measure of arc PQR by inscribed angle theorem. Okay, and therefore 110 degree equals half of measure of arc PQR, and therefore measure of arc PQR equals 110 degree into 2 equals 220 degree. Equation second. Now we are interested to find measure of arc QR, but arc QR is intercepted by inscribed angle QPR. We must know about measure of angle QPR. Okay, and to get measure of angle QPR, let's talk about triangle PQR, in which angle PQR is 70 degree. Just we calculated, and two sides are congruent, means triangle PQR is isosceles triangle. Okay, by isosceles triangle theorem, angles opposite to congruent sides are congruent. Okay, we may show angle QPR congruent angle QRP, and let the measures of these angles be x and x. Okay, x degree. By applying angle sum property of a triangle, we can find value of x. And what is the value of x? That is measure of angle QPR, and angle QPR is half of measure of arc QR, and therefore measure of arc QR equals twice of angle QPR. Using that, we will find measure of arc QR. Okay, now let's talk about triangle PQR. In a triangle PQR, PQ congruent RQ, since it is given, and therefore angle QPR equals angle QRP by isosceles triangle theorem. Okay, and therefore angle QPR equals angle QRP equals x degree. Say now angle QPR plus angle QRP plus angle PQR equals 180 degree. Since angle sum property of triangle, and therefore x degree plus angle PQR, which is 70 degree, equals 180 degree, and therefore 2x degree equals 180 degree minus 70 degree. 180 degree minus 70 degree equals 0 minus 0 gives us 0, 8 minus 7 gives us 1, and 1 minus 0 gives us 1, means it will be 110 degree, and therefore x degree equals 110 degree upon 2. 2 5s are 10, 2 5s are 10, means 55 degree. Okay, and therefore angle QPR equals angle QRP equals 55 degree. Equation third. But angle QPR equals half of measure of arc QR by inscribed angle theorem. Inscribed angle theorem, and therefore 55 degree equals half of measure of arc QR, and therefore measure of arc QR equals 55 degree into 2 equals 110 degree. Equation fourth. Okay. Question third. Quadrilateral MRPN is a cyclic. Angle R equals 5x minus 13 degree. Angle N equals 4x plus 4 degree. Find measures of angle R and angle N. Okay. Question third. Solution. First of all, let's draw a situational diagram. Situation is about cyclic quadrilateral MRPN. Let's draw a cyclic quadrilateral and let's call it as quadrilateral MRPN. Okay, cyclic quadrilateral MRPN. Cyclic quadrilateral MRPN. MRPN. Either in clockwise order or in anti-clockwise order, we should name that quadrilateral. Angle R is 5x minus 13 this much degree, and angle N, okay, angle N 4x plus 4, 4x plus 4 this much degree. Find measure of angle R, means what is the value of 5x minus 13, and angle N, what is the value of 4x plus 4. Okay, let's mention here. Here, quadrilateral MRPN is cyclic. Okay, and we know that opposite angles of cyclic quadrilateral are supplementary. We are interested with a pair of angle R and angle N. That's why let's write here. Therefore, angle R plus angle N equals 180 degree. Since opposite angles of cyclic quadrilateral, therefore 5x minus 13 this much degrees, 5x minus 13 degree plus 4x plus 4 degree equals 180 degree. Now let's bracket off. Therefore 5x minus 13 plus 4x plus 4 equals 180. 5x plus 4x gives us 9x, and minus 13 plus 4 gives us minus 9 equals 180. And therefore 9x equals 180 plus 9, that equals 189, and therefore x equals 189 upon 9. 9 ones are 9, 9 twos are 18, 9 ones are 9, and therefore x equals 21, and therefore 5x minus 13 equals 5 into 21 minus 13. Okay, 21 5s are 105. Okay, minus 13. Now 5 minus 3 gives us 2, and 9 minus 1 gives us, 10 minus 1 gives us 9, means it will be 92. Another 4x plus 4, 4x plus 4 equals 4 into 21 plus 4. 21 4s are 84 plus 4 equals 88. Now you may note 92 and 82 is a pair of supplementary angles, 92 degree and 88 degree. Okay, means our answer is correct, and therefore angle R equals 5x minus 13 this much degree equals 92 degree, and angle N equals 4x plus 4 this much degree equals 88 degree. Question 4th. In figure, seg radius is the diameter of the circle with center O. Point T lies in the exterior of the circle. Prove that angle RTS is an acute angle. Angle RTS is an acute angle. What is an acute angle? An angle whose measure is less than 90 degrees is called as an acute angle. Means let me mention what to prove here. To prove angle RTS is an acute angle means angle RTS is less than 90 degree. Okay, that we are interested to prove. Question 4 solution. Now if you observe carefully, you may note T is in exterior of a circle and RT intersect a circle in a point. Let that point be point P. Okay. Now if we draw seg PS, then we get an angle RPS. Isn't? Now angle RPS is an angle inscribed in semicircle because seg radius is the diameter, and we know that diameter divides a circle into equal parts. Each part is called as semicircle. Angle inscribed in semicircle is right angle means angle RPS equals 90 degree, and we are interested to show that angle RTS is less than 90 degree. Angle RPS and angle RTS, these are interrelated angles. How? Angle RPS is exterior angle of triangle RTP. Sorry, of triangle STP. And we know that exterior angle of triangle is greater than each of its remote interior angle, means we can show angle RPS is greater than angle PTS, means 90 degrees greater than angle PTS, means 90 degrees greater than angle RTS, means angle RTS is less than 90 degree. That is angle RTS is an acute angle. Okay. Let's mention these things in proof. Proof. Let RT intersect a circle in point P. Draw seg PS. And therefore, from figure, angle RPS equals 90 degree. Number 1, since angle inscribed in semicircle RPS, since RS is diameter, but angle RPS is exterior angle of triangle PTS. Okay, of triangle PTS, and therefore angle RPS is greater than angle PTS. Since exterior angle theorem of triangle. And what is exterior angle theorem of triangle? Exterior angle of a triangle is greater than each of its remote interior angles. Okay, and therefore angle RPS is greater than angle PTS. We can call as angle RTS, since R dash P dash T, and therefore 90 degree is greater than angle RTS, and therefore angle RTS is less than 90 degree, and therefore angle RTS is an acute angle. Question 5. Prove that any rectangle is a cyclic quadrilateral. Question 5. Solution. Statement is about a rectangle. Let's draw a situational diagram. A rectangle. What is a rectangle? A rectangle is a quadrilateral whose every angle is a right angle. Let the name of this quadrilateral be quadrilateral PQRS, such that its every angle is a right angle, then quadrilateral PQRS will be a rectangle. Let me mention here given quadrilateral PQRS is a rectangle. And what to prove? To prove that every rectangle is a cyclic quadrilateral. Okay, means to prove here quadrilateral PQRS is a cyclic quadrilateral. Okay. By the definition of cyclic quadrilateral, if all the vertices lie on a circle, then that quadrilateral is called as cyclic quadrilateral. And we learnt theorem of cyclic quadrilateral. According to that, opposite angles of cyclic quadrilateral are supplementary, and conversely, if opposite angles of quadrilateral are supplementary, then it is a cyclic quadrilateral. Means we need to prove either angle P plus angle R equal to 180 degree, or angle Q plus angle S equals 180 degree. Okay, if we are able to prove like that, then we may conclude, we may declare quadrilateral PQRS is a cyclic quadrilateral. Yes, easily we can. Let's see how. Proof. Quadrilateral PQRS is a rectangle, and therefore angle P equals angle Q equals angle R equals angle S equals 90 degree. Since angles of a rectangle, okay, and therefore angle P plus angle R equals 90 degree plus 90 degree equals 180 degree. But it is a pair of opposite angles, but it is a pair of opposite angles of quadrilateral PQRS, and therefore by converse of cyclic quadrilateral theorem, quadrilateral PQRS is cyclic quadrilateral. Okay, is cyclic quadrilateral. Hence the proof. Question 6th. In figure, altitudes YZ and XT of triangle WXY intersect at P. Okay, intersect at P. Prove that quadrilateral WZPT is a cyclic, and number 2, points X, Z, T, Y are concyclic. Okay, now let's prove these things one by one. Question 6, solution. Okay. Proof. Here, in a triangle WXY, you may note YZ perpendicular WX and XT is perpendicular to WY, and therefore angle YZW equals angle YZX equals 90 degree, angle XTW equals angle XTY equals 90 degree. That is angle YZW we may call as PZW. Angle PZW equals angle XTW. Angle YZW we called as angle PZW, and angle YZX we can call as angle PZX. Angle PZX equals 90 degree. Similarly, angle XTW we can call as PTW. Angle PTW equals angle XTY we can call as angle PTY. Angle PTY equals 90 degree. Common curly. Since X dash P dash T and Y dash P dash Z, Y dash P dash Z, and therefore in quadrilateral, first of all we are interested to prove that quadrilateral WZPT is a cyclic. Means if we prove that angle WZP plus angle WTP equals 180 degree, then by converse of cyclic quadrilateral we may declare it is cyclic quadrilateral. Therefore in quadrilateral WZP, in quadrilateral WZPT, angle PZW plus angle PTW, angle PTW equals 90 degree plus 90 degree equals 180 degree, and therefore by converse of cyclic quadrilateral theorem quadrilateral WZPT is cyclic. Okay, let's call it as number 1. Now we are interested to prove that points X, Z, T, Y are concyclic. Here you may note point X and Y lie on a line XY. Okay. Point Z and T are on same side of line XY such that angle XZY congruent angle XTY each 90 degree. And we learned that if 2 points on a line sustained equal angles at 2 distinct points on same side of the line, then 4 points are concyclic. Means we may declare like this. Okay, here these 2 angles are congruent, subtended by seg xy on same side of xy, and therefore we can declare. Now angle XZY, angle XZY congruent angle XTY. Since each 90 degree, we know that if 2 points on a line subtend equal angles at 2 distinct points, 2 distinct points on same side of a line, then those 4 points are concyclic. Okay, and therefore as here points X, Y subtend equal angles at Z, T on same side of line XY, and therefore X, Z, T, Y are concyclic. Okay, hence the proof. Let's see question 7. In figure, measure of arc NS equals 125 degree. Okay. Measure of arc EF equals 37 degree. Find the measure of angle NMS. Angle NMS equals what much? Okay. Now you may note angle NMS is neither central subtended angle nor inscribed angle. Its vertex lies in exterior of a circle. And we learnt, if lines containing chords of a circle intersect each other in exterior of a circle, then angle between them is equals half of difference of measures of arcs intercepted by that angle. Means half of difference of measure of arc NS and measure of arc EF. Okay, let's mention directly here. Here from figure angle NMS equals half of, in a box bracket, measure of arc NS minus measure of arc EF, bracket closed, dash dash dash, since vertex M of angle NMS lies in exterior of circle. Okay, that equals half, in a box bracket, measure of arc NS is 125 degree minus measure of arc EF is 37 degree. That equals half into 7 cannot be subtracted through 5. That's why by taking carry from 2 we get here 15. 15 minus 7 gives us 8. Okay, then there will be 1. 3 cannot be subtracted through 1. Therefore we take carry. Then it gives us 11. 11 minus 3 gives us, yes, 8. And 2 1s are 2, 2 4s are 8, 2 4s are 8. 44. Okay. Now, therefore, we can mention there angle NMS equals 44 degree. Okay, angle NMS equals 44 degree. Question 8. In figure, chords AC and D intersect at B. If angle ABE equals 108 degree, measure of arc AE equals 95 degree. Find measure of arc DC. Okay. From figure, you may note vertex B of angle ABE is in interior of a circle, and we know that if the vertex of an angle lies in interior of a circle, then measure of such angle is equals half of sum of measure of arcs intercepted by that angle itself and an arc intercepted by its vertically opposite angle. Means from figure, angle ABE equals half of measure of arc AE plus measure of arc CD. Okay. Now let's mention here from figure, angle ABE equals half of, in a box bracket, measure of arc AE plus measure of arc DC or CD. Okay, dash dash, since vertex B of angle ABE lies in interior of circle. Okay. Now let's put those values which we know. We know about angle ABE having measure 108 degree. Therefore, 108 degree equals half in a box bracket measure of arc AE, which is 95 degree, plus measure of arc DC, we don't know, and therefore 108 into 2 which was a divisor at right side now is multiplier at left side, equals 95 degree plus measure of arc DC, and therefore 2 8s are 16, carries 1 2 0 0 and 1 1, 2 1s are 2. 216 degree equals 95 degree plus measure of arc DC, and therefore measure of arc DC equals 216 degree minus 95 degree. 6 minus 5 gives us 1, 11 minus 9 gives us 2, and 1 minus 0 gives us 1, 121 degree, and therefore measure of arc DC equals 121 degree. Okay, we are interested to find measure of arc DC, which is 121 degree. Thank you.